Hey, I'm G. Welcome to the Stuff You Should Think About, where I answer questions about everyday phenomena and objects. So, how's it going? Hope your day is going the way you wanted it to go. So, today I want to talk about something that sounds kind of sci fi, but it's real life pollution sniffers in China. Like actual people whose job is basically smelling the air. I know, that sounds like a bad superhero pitch, but in some Chinese cities, environmental teams literally walk around and sniff for pollution as part of air quality enforcement. They're not just wandering around taking random whiffs either. They're trained inspectors, and their nose is kind of the first alarm before the tech kicks in. The way it usually works, at least from what's been reported, is they go through training to recognize different industrial smells. So, things like that sharp, choking smell you get from sulfur or heavy smoke, or that sweet, kind of sickly scent you sometimes notice near paint or solvents, that's often volatile organic compounds, or VOCs. Then there's the more metallic or acrid notes that can hint at nitrogen oxides or other combustion stuff. They're basically building a mental library. This smell, probably that kind of factory, and they don't just rely on the nose and call it a day. When an inspector picks up something weird, like, say, a chemical or a smell drifting out from behind a warehouse, they pull out sampling gear. Picture these small pumps and canisters or bags that suck air from the exact spot where the odor's strongest. They hold it near a vent or near a drainage outlet, or even right in the middle of a smoke alley if they have to. Those samples go back to a lab where they can actually test what's in there, which gases, roughly how much, whether they match anything that's supposed to be coming from nearby factories. So the human sniffer is like the pointer dog, and the lab is the one that confirms. Yeah, this is over the line, or nah, it just smells nasty, but it's within limits. And you can imagine that's a tough job. You're out there at weird hours sometimes because factories don't always pollute when it's convenient. Some will try to dump emissions late at night or on foggy days, hoping nobody notices. So you've got inspectors walking through industrial zones or along rivers using their noses to catch those moments when the air suddenly changes. You know, that thing where you're walking and you go, whoa, what was that? Except instead of complaining, they have to follow it. But there's a limit to what a human nose can do. People get tired. They get used to a smell after a while. And I mean, nobody's sniffing a smokestack that's 50 meters up. And if you got a whole city full of factories and truck ports, you can't walk everywhere. I don't have time to babysit adults, and these folks don't have time to babysit every chimney in China, you know. So the next step has been adding tech into the picture, what you might call electronic noses. Governments and local environmental bureaus in China have been rolling out a mix of sensors on the ground, sniffing devices in inspectors' hands, drones in the air, and even satellites looking down from orbit. The human nose is still there, but now it's a part of a bigger toolkit. You'll see inspectors carrying handheld meters that beep or flash when gas levels spike. You'll see steel boxes on poles that quietly sample air all day and send data back. And then you got these sniffer drones. People talk about little flying robots that can literally fly into a smoky plume and see what's inside without anyone breathing it in. So, yeah, we're kind of moving from, does that smell weird, to, okay, this sensor says your sulfur dioxide is at this number. Your nitrogen oxides are at that number. And here's the legal limit. In the next part, I'm going to break down how those electronic sniffers actually work. Because it's not magic. It's just a lot of tiny, grumpy little sensors arguing with each other about what they're seeing in the air. All right, so let's talk about gadgets. When people say electronic nose in this context, they basically mean a bundle of sensors tuned to different pollutants. In China, a lot of this gear focuses on gases like sulfur dioxide, SO2, nitrogen oxides, often just called NOx, ozone, and a whole zoo of VOCs. Two big categories you'll hear about are electrochemical sensors and infrared sensors. Electrochemical sensors are kind of like tiny controlled batteries. When a specific gas hits them, it triggers a chemical reaction that makes a small electrical current. More gas, more current. So you can have one that's really sensitive to SO2, another one tuned to carbon monoxide, stuff like that. They're small, relatively cheap, and good for handheld devices or drones. Infrared sensors work differently. Certain gases absorb infrared light at very specific wavelengths. So you shine a bit of IR light through the air, measure how much gets eaten up, and that tells you how much of a gas is in there. This is used a lot for things like CO2 and some other pollutants. It's more like how much light went missing. Okay, that's your concentration. Now, how do these show up in the real world? You basically got three big setups: handheld devices, fixed stations, and drones. Handhelds are what inspectors carry when they're out walking. They might have a little display with real-time numbers. SO2, 40 micrograms per cubic meter, 60, 120. If they walk past a factory gate and suddenly the numbers jump, that's a clue. Sometimes they'll combine that with their own nose and say, yeah, this isn't just traffic exhaust. Fixed stations are the boxes you see on poles, building roofs, or at the edge of industrial parks. China's built out a pretty big network of these. Some are official national monitoring sites, others are more local. They inhale air all day, log the concentrations every few minutes, and send that to a central platform. Those give you the big picture. Is this district getting a spike at 2 a.m. every night? Is the wind blowing something nasty from one side of town to the other? Then there are the fun ones, sniffer drones. I kind of love this idea, not breathing in the bad stuff yourself, just sending up a robot. These drones carry a lightweight sensor package underneath. When environmental staff see a suspicious plume coming off a chimney, they can fly the drone right into it, sometimes at different heights, and see how the readings change. In coastal areas, some reports mention drones flying over shipping lanes or ports to check what's coming off the stacks of these big ships. But raw sensor readings are messy. You can't just see a number and slam a factory with a fine. So they do a bunch of processing. First is calibration before deployment. Sensors are checked against known gas concentrations in the lab. And in the field, they'll periodically compare a portable device to a more accurate reference station to make sure it's not drifting. Sensors age, they get dirty, humidity messes with them. You got to babysit the hardware a little bit. Then there's filtering out background noise. Cities already have traffic, cooking fumes, power plants, all that stuff. If you're trying to figure out whether one specific factory is cheating, you need to know what normal looks like on a given day with a given wind pattern. So data systems will look at trends over time, like wind direction, and combine multiple sensors. If 3 stations downwind of a factory all spike at once in the chemicals that factory uses, that's stronger than one lonely reading. Finally, those numbers have to be matched against legal limits. China has national air quality standards that say, average NO2 over an hour shouldn't go above a certain micrograms per cubic meter. Same for SO2, PM 0.5, all that kind of stuff. The software compares the incoming data to those thresholds. If it sees repeated exceedances in pattern that points to a specific source, that's when alarms start going off on somebody's dashboard. So it's this whole pipeline. Gas in the air hits a sensor. Sensor spits out a signal. Computer cleans it up, compares it to the rules, and then flags it for a human inspector. And that's where we get to the part I kind of like the most. What happens when you mix human judgment with all the sniffing data to actually catch polluters in real time? So, okay, you got all these numbers streaming in from people's handheld sniffers, from fixed stations, from drones buzzing around like mosquitoes you keep slapping because they keep biting you. How does that turn into, hey, Factory X, we know it was you? This is where inspectors and algorithms kind of tag team a common pattern in China. Based on what's been reported, it's something like this. The monitoring system notices a sudden spike in, say, sulfur dioxide in an industrial zone. It checks wind direction. Maybe it's blowing from the northwest. It looks at which factories in that direction are known to emit SO2. If one particular plant has a history of borderline emissions, the system might flag it. Within minutes, local inspectors can get a message. Possible illegal discharge near Plant A. Check now. Then they head out, sometimes with handheld sensors, sometimes with a drone. The drone might fly over the plant smokestack, sniff the plume, and send back readings. If those readings are way above what that plant is allowed to emit, and it lines up with the fixed stations on the ground, that's pretty strong evidence. In some cases, authorities have reportedly used that kind of quick response to catch factories that only turn on extra pollution controls when they think somebody's watching. There are also surprise inspections, where the tech is more like a bag-up witness. An inspector shows up unannounced at a facility, checks their equipment, looks at their self-reported emissions data, and then compares that to what nearby sensors and past drone flights have seen. If a company reports nice, clean numbers, but the external sniffers keep seeing big plumes of VOCs every night at 11 p.m., somebody's not telling the truth. Ports and shipping are another big one. Big ships burn heavy fuel oil that can be really dirty unless they use cleaner fuel or scrubbers. In some Chinese ports, drones or boats with sensors have reportedly been used to sample exhaust above ships at anchor. If the sulfur content looks too high, that can trigger a closer inspection. It's sort of like random breath tests for cars, but for giant engines. Algorithms help stitch this all together, matching emission patterns to specific stacks, tracking repeated violations, and even ranking which sources contribute the most to a bad air quality day. But at the end of the day, a human still has to decide, is this enough to act on? Do we send inspectors? Do we fine them? Do we shut something down? The tech speeds up the hunt, but it doesn't replace judgment. Now, all of this high-tech sniffing has some upsides. It can make pollution control more precise. Instead of just banning everything and hoping for the best, you can see who's actually causing the spike and focus enforcement there. It can also make it harder for companies to cheat quietly because the air itself is telling on them. You don't have to rely on paperwork that might be, let's say, creatively filled out. But there are questions that come with it. Anytime you've got dense monitoring, people worry about fairness and privacy. These systems are mostly looking at emissions, not individuals. But imagine living near a factory that's constantly flagged. You might feel like your whole neighborhood is under a microscope. And smaller companies might argue they don't have the money to upgrade, even if the data says they're a problem. Who gets help? Who gets punished? That's a policy choice, not a sensor choice. There's also the risk of leaning too hard on numbers that can still be wrong. Sensors drift. Drones can sample in weird wind conditions, and data can be misinterpreted. Ideally, you'd have transparency. How the data is used. How often the gear is checked. What rights companies and communities have to see or challenge the readings. I might be wrong, but I feel like that's going to be a bigger part of the conversation if more countries copy this approach. And that's the thing. This kind of system probably will spread. Pieces of it are already popping up around the world. Sensor networks in European cities, drone inspections in the U.S., satellite tools that can spot big methane leaks. China's version is just one of the more intense examples because the air pollution problem there has been so serious and the response has been you know, pretty heavy duty. So we've gone from human pollution sniffers walking around saying that smells off to drones and sensor grinds that can link a plume in the sky to a factory on the ground in near real time. That's impressive and a little bit intimidating. I guess the way I feel, if we're going to watch anything that closely, watching pollution is not a bad place to start. Anyway, I hope that gave you a picture of how these sniffers, human and electronic, fit together. Next time, I kind of want to dig into what it feels like to live under skies that are being measured that closely all the time, and what that does to people's daily lives. But for now, I hope your air is clean, your day is calm, and I'll talk to you later. Statements are based on current understanding and public information. This is not professional advice. If you need legal guidance that affects your health, safety, finances, or legal situation, talk to a qualified professional who can look at your specific circumstances. Thank you for tuning in to this episode of The Stuff You Should Think About. I'm G, and I'm out.